Okay, we're going to look at this question. This is a very difficult integration by substitution question. First thing we've got to do is use partial fractions to show that 1 over u squared minus 1 is identically equal to a half upon 1 over u minus 1 over u plus 1. Now we're going to assume that we can do this. Have a look at partial fraction stuff. It's not overly difficult to do this. But part B is a tricky bit. It says using your answer to part A and the substitution, u is equal to e to the x, show that 1 over e to the x minus e to the minus x dx is equal to this. Now the first thing I'm going to do is change my integral. I'm going to write I for my integral. It was 1 over e to the x minus e to the minus x. And what I'm going to do, I want to get it in this sort of form. So 1 on top, or well, something on the top, but you want to get u squared minus 1. So it's getting this minus 1 is going to be the tricky bit. So what I'm going to do here is I'm going to multiply the top line and the bottom line of this integral by e to the x. So 1 times e to the x is just e to the x, and on the bottom line, e to the x and times e to the x is just e to the x squared. E to the minus x times e to the x would just become e to the minus x plus x, which is e to the 0, which is just equal to 1. So that's what we're looking for. So that was just by multiplying top line and bottom line by e to the x. It's now almost in this form, 1 over u squared minus 1. We'll see what happens here. So the substitution we would use was u is equal to e to the x. So you've got to change everything. So this e to the x, we have to get rid of it. This e to the x, we get rid of u. And we have to change our dx to be du. So we have a bit to do here. So the first thing you do is you differentiate your u with respect to x, giving you e to the x, and then multiply across by your dx. I know that's not really what you're doing, that's mathematical nonsense. So if you put an integration sign around it, that makes sense. So that means we're changing our integration sign, our 1 over e to the x's, and our dx. All those three things just become the integral of du. So our I so far will become, I will just become, it's going to become, where are we, the integral, and what have I just said, my integration sign, my e to the x and the dx just becomes du. So you're just left with 1 over, and remember this u was equal to e to the x, so that just becomes 1 over u squared minus 1. So that's what we've got. Okay, now this would be a partial fractions question, and this is what we did in part A. So in part A, we showed that this was the same as a integral of a half upon, and what was it, 1 over u minus 1 minus 1 over u plus 1. Okay, now what I could do is take a half outside the bracket, and then both of these things I can integrate. So if you can integrate both of those, so I'll just do my square bracket here. I've integrate this. I'm going to get ln of u minus 1, modulus of that, minus ln of u plus 1. And then I'd also have a constant of integration. So let's sort that out. Using your rules of logs, log of something minus log of something else, you could just write that as log of u minus 1 over u plus 1. Then plus your constant of integration, and then remember u was equal to e to the x, so this whole thing will become half upon ln of e to the x minus 1 over e to the x plus 1, and hopefully that's what we're looking for. It is indeed. Happy days, we have done it. So it's a very difficult integration by substitution question. The first part was integration by parts. Hopefully that's easy enough for you to do. But you can see in an exam they've shown you that what the integration by parts is, so that's how you use it for the next part of the question.